Okay, so now let's try to get residual variability. Now, residual variability is that leftover within group, within sample variability, right? Now, in order to get leftover, the formula for this is going to be, the variability residual. In order to get that, you get the residual sum of squares and divide by the residual degrees of freedom, right? The residual sum of squares is literally going to be the leftover. SS total minus SS subject plus SS between, right? And my degrees of freedom residual is going to be a conglomeration of other degrees of freedom available to us times the degrees of freedom between. Okay, so we know that in order to find these, we're going to need to find these, and also this one, right? So the total variability, let's start there. We know, we know this one pretty well. This is variability, sort of the spread of all the data points in all of our samples away from the grand mean. Spread of all data points away from grand mean. And so we actually don't need the variability here, and we don't need this variability either. What we really need is this sum of squares total. And that's going to be for each data point, no x bar or anything. Get the squared distance from the grand mean, so for each data point. Okay, so now that we have that, we don't really need this, but we could find it anyway. So the degrees of freedom total is going to be nk minus 1, so the total number of data points minus 1. Now let's talk about within subject variability. This is the spread of each case away from grand mean. And when you talk about each case can sort of be represented, the point estimate of it can be its own mean. So each case's mean, right? So that's how I want you to think of it. Each case is sort of represented by its own little mean. And so that's why we're using its means to calculate this distance. So the SS subject is going to be the distance of each subject level mean away from the grand mean squared. And in order to say subject level, you got to put that n here so that it knows do this for each subject, not do this for each data point or do this for each, if we put a k there, it would be do this for each group, right? And we want it to count more if they participate in more measures, right? So if the measures are repeated over and over again. So we want to put in the number of k. And so that gives us our sum of squares for each subject. And once we have those two, we could find this, right? As well as sum of squares between. And then we also need the degrees of freedom for within subjects, just because we're going to need that to find the degrees of freedom residual. This guy, he makes us do all this jump through hoops. Okay, so the degrees of freedom for each subject, for a subject level variance, is going to be n minus 1, the number of subjects minus 1. Okay, so here's example 1. Which is more prevalent on Facebook? Tagged, uploaded, mobile, or profile photos? And so these are all different kinds of photos, but one person, or one Facebook user, presumably they're a person, they're sort of the linking factor of all four of those measures, right? So what's our null hypothesis? Well, it's that all of these groups really come from the same population. The reason I use this P notation is for just different types of photos, right? And I'll call this 1, 2, 3, and 4. Also, it makes it easier for me to write my alternative hypothesis, so it has a practical significance. So all mu sub p's are not equal. So they're not all equal. All are, yeah, all mu's are not equal. Yeah, so at least one is different. So the significance level, we could just set it as alpha equals 0.05 just by convention. Because we're going to be using an F value, we don't have to determine whether it's one-tailed or two-tailed. It's always one-tailed. F is cut off on one side and skewed to the right. So it's always going to be just on the positive side. And so let's draw our decision stage. We could draw our F distribution. We know that it ends at 0 if alpha equals 0.05. What's the F here? Well, remember, in order to find F, we need to know the denominator's dF as well as the numerator's dF, right? And so here, we know that F in the numerator is going to be degrees of freedom between groups, right? And that's k minus 1. There's 4 groups, so it's going to be 3. And the degrees of freedom residual is going to be degrees of freedom between times degrees of freedom subject, right? So we're going to need to find degrees of freedom subject, right? And degrees of freedom subject is going to be n minus 1. Now, let's look at our data set in order to figure out how many we have in our sample. Okay,